Now, what if we want to find the length of the entire cable? So what we can do here is take advantage of the calculus. Alright, but before that, let's get the equation first of the cable, equation of the parabola. So recall that when we have a parabola that's opening upwards, its equation must be x squared is equal to 4ay, no matter what. So now, since our coordinate at this point is 0, 0, then this point must be negative 58.58, comma 40. And on the other hand, this must be 41.42, comma 20, this point, right? X and y coordinate. So if we do that, here, 41.42 squared is equal to 4a. We need to find a, and then y is 20. Then a must be A must be 21 point, let's say 45, 21.45. Therefore, our equation must be for 21.45 y. If we let this, if we let this be in terms of y, we just have to divide both sides by this value. Alright, so it will become 1 over 4, 21.25 x squared. That would be 1 over 4 times 21.45, 0 point or this value. Or let's just leave it like that, 41.1 over 41.45 x squared. 21.45. This is for x squared. Now recall in calculus that if this is the dx, dy, and this must be dz or ds, whatever you call it, this is the tiny length of the cable here. If we zoom very very close here, it will have something like this one. So that's dz, and its run is dx, and its rise is dy. Somewhat it will form a right triangle. So if we get its relationship through Pythagorean theorem, then this will happen. Alright, if we force dx squared, force factor that, what do we get? So we get this dy squared over dx, right? So if you bring this back, you're gonna observe that this 2 will just cancel out. The dx squared will form exactly like this. So if we factor out this, it will form like this, right? dz squared. So now here, we can say that dx squared is equal to dy or over dx, or the derivative of our equation with respect to x squared, right? Times dx squared and dc squared. Now, and if we get the square root of both sides and consider only the positive value, then this must be our equation. Times dx. The other squared will cancel, or the squared will just cancel out. Recall that this z refers to cable's length. Cable's length. And this is just the derivative of the equation of the curve of the parabola. So first, let's get its derivative. So what's the derivative of that equation? So it's simply 2 over 4 times 41.45 x. Bring this down, subtract 1 to that 2, and this is the derivative, right? Then substitute that to our function. So dz, the length of the cable, plus derivative, which is 2 over 4, 41.45 x, and then square it, and then the dx, right? If we want to integrate this, we're gonna get the z value, but from where and to where? So this will give us the answer, but from where? So let's go back to our given. We know that this point here, in terms of x, is negative 58.58, right? Because this is our origin, so negative 58.58, while this point right here is 41.42, right? So that would be our intervals, or the upper and lower boundary. So we want the length of the cable specifically from this x to this x, right? These intervals, what would be the length of this? So let's plug that in to our integrals. Integral, ito 58.58, and here 41.42. And let the calcu do the magic. So the total length of our cable must be, so from negative 58.58 to 41.42, square root of 1 plus derivative squared, that's 2 over 4, 41.42. And you can see the total length of our cable is 100 feet. 100 feet. So notice that this answer is just a coincidence. It's just a coincidence that our x 100 feet is also equal to this one. It's just a coincidence. So that's how you find the total length of our cable.